Grade Chemistry. This lesson is on the subject of significant figures. So, in short, significant figures tells you how many digits you should use in your answer to a chemistry problem. So we'll learn the rules for that. So rounding is a process of limiting the number of digits after a decimal point. For example, rounding the following number to three significant figures, 3.47658, you would come up with those three digits, and so that would be, the 6 would round the 7. The 6 is the rounding digit, and it would round the 7 up to an 8. So it's 3.48. Okay, here are the rules for significant figures. They're not going to make a lot of sense until you just get into doing them. All non-zero digits, 1, 2, 3, 4, 5, and so on, are significant. Zeros to the left of the leftmost non-zero digits are never significant. Zeros in between non-zero digits are always significant. And zeros to the right of the rightmost non-zero digit are significant if there is a decimal point, and not significant if there is not a decimal point. And finally, this last rule is the trickiest one. The significant figure answer must have the same number of digits to the left of the decimal as the calculator answer. So let's just jump into some examples. So here's an example. If you take this number, the leading zeros are never significant. The zeros between two non-zero digits are always significant, and trailing zeros are significant only if there's a decimal point, and in this case there is a decimal point. And of course the non-zero digits 2 and 4 are always significant. So if you took the number 20,000, how many significant figures? It just has one significant figure because the trailing zeros are not significant because there is no decimal point. So let's take some numbers here. And you can pause these as you go along. I'm going to move kind of quickly, but you pause them and see if you can do them. How many significant figures here? There's 3. All non-zero digits are significant. 3045, how many? 4. A zero between non-zero digits is significant. 6020, 3. No decimal, so the trailing zero on the right is not significant, or some books will say it's uncertain. We're going to say it's not significant. Okay, how about this number? 5. All the non-zero digits are significant, the 3 zeros are not. 10,000? 1. There's no decimal, so the trailing zeros are not significant. This number? 8. All of those are significant because there is a decimal. Okay, this one? 4. The 1 and the 3 zeros to the right are significant. The 4 zeros to the left are not significant. Okay, examples. When multiplying or dividing numbers, the answer should contain the same number of significant figures as the number with the least number of significant figures that are being multiplied or divided. I'm going to tell you this rule is almost the only one you need to know for significant figures, because 98% of the time when you're going to deal with significant figures with a multiplication or a division. Okay, so let's see the example. So if you multiply these numbers, you'd get the calculator answer of 4.2941. So 2.3 has 2 significant figures, 1.867 has 4 significant figures, therefore the answer can have only 2 significant figures. It's whichever one of those is the least number of significant figures, so the answer would be 4.3. And the rules for division would be the same. So if you understand this one slide, you understand almost everything you need to know about significant figures. Okay, so the rules for multiplication: the product should contain the same number of sig fig as the multiplicand, that's the number being multiplied, with the least significant figures. That's what we just said. The final sig fig answer must have the same number of digits to the left of the decimal point as the calculator answer, with the non-sig fig digits represented as zeros. That one's a little more complicated. We'll give some examples though, okay? Alright, so let's practice. You can always pause the video, so do that, pause. Okay, and the significant figure answer is 8, because 2 and 4 each have one significant figure. Okay. Pause. Okay, so the significant figure is 42. 8.1 limits the answer to 2 sig fig, and the 2 after the decimal is rounded down. Okay, pause. Okay, and you get 0.34. 0.104 has 3 sig fig and 3.3 has 2 sig fig, so the answer is limited to 2 sig fig. The answer is rounded down to 0.34. Okay, this one, 64.1. Each of the multiplicand has 3 sig fig, so the answer is limited to 3 sig fig. The 5 is rounded, rounds the 0 up to a 1, so it's 64.1. Okay, this one, pause. And the answer is, this one's trickier, 40,000. The 5 limits the answer to 1 sig fig. So don't make the mistake of thinking that the sig fig answer is 4. It's limited to 1 sig fig, which is the 4, but it must have the same number of digits, the final sig fig answer, as the calculator answer. The calculator answer has 5 digits, 42735. So the sig fig answer must also have 5 digits. So after the 4, the 0, that you place zeros. So you have 5 digits. Okay, pause, and you get 0.0010. The 0.10 limits the answer to 2 sig fig. The 4 is rounded down to a 0. The 1 and the trailing 0 are the only sig fig. This one, pause. Okay, this one's 710. Each of the multiplicands has 2 sig fig, so the answer is limited to 2 sig fig. That's the 7 and the 1. But the final sig fig answer must have 3 digits, and so that final digit is after the 7 and the 1 is going to be a 0. Okay, now division, same thing. If you do the division, there's your calculator answer. What's the sig fig answer? 1.2. The 5 rounds the second one up to a 2, so 1.2. Okay, this one, 3.4. 3400 has no decimal, and it has 2 sig fig. 987 has 3 sig fig, so the answer has 2 sig fig, so it's 3.4. Okay, how about this one? It's 200. 0.8 is 1 sig fig, so the answer can only have 1 sig fig, and that would be that 2, that leading 2. The 3 rounds the 2 down, so it stays at 2. In other words, it doesn't round up to 3. There is no decimal in the final answer, making the 00 not significant, okay? That's important. If you put a decimal after the 00, they would be significant. So it's 200. Okay, you're almost never going to add or subtract using significant figures, but the rules are, for subtracting, you line up the decimals. You always have to do that when you add or subtract. And then you do your addition subtraction. The sig figs are determined by the number with the least number of digits after the decimal. So it's a different way to do it, but you end up pretty much with the same number of sig fig. So there, we're going to add those two numbers. And then first we're going to put a line right next to the 5, because that has the least number of digits. The 23.45 has the least number of digits after the decimal. So you put a red line there, and then you simply add. And so everything to the left of that red line, 2918, are significant. The 6 is the rounding digit, so there we go right there. And so your final answer is 29.19. Okay, and that takes care of our lesson on sig fig. Again, if it seemed complicated, just remember, the only rule you really need to remember is the one for multiplication and division, and that one's pretty easy.